So Windows Output. Hello everybody, welcome back to the channel, and today we're going to be explaining how to solve an AMC 10 geometry question. So the question asks for, given a regular quadrilateral, you have to find what is the relation of the area of the shape quadrilateral formed by connecting the midpoints in relation to the bigger quadrilateral. And just to be clear, the answer for this question will be half, and you guys could go prove why. But today what we're going to explain is how do you prove this shape inside is a parallelogram. Now, to prove this question, we have multiple methods. We have a geometry method, or we can have a method proved with vectors. For the geometry method, it's really simple. You draw a line connecting the two side points of the bigger quadrilateral. Now, you could look at the triangle formed from one side of the shape. This line, let's call this line AB, and let's call this line CD. You could prove these two lines are parallel. Now, the reason why they're parallel is because the triangles they are on are similar. They share the same angle, and the sides that they share are in relation to one another. So you could prove that these two bases of these two triangles are indeed parallel. Now, after you prove this, you do the same for the other side, this side of the triangle, of the quadrilateral, and then you could prove the same thing by drawing another opposite line of the quadrilateral's diagonals to prove essentially the same thing. You prove those two lines to be parallel. Now, after you finish all of this, you will prove that the shape inside is indeed a parallelogram. Now, let me revert this back to the original. Now, we're going to explain the method using vectors to solve. The one using vectors is simple too, like the one with the geometry. To solve this with vectors, you could assume this is point A, B, C, D in the quadrilateral. Now, we'll also label the midpoint, so let's call this E, F, G, and H. Let's scroll down a bit, but look at the quadrilateral. So, vector AE, sorry about this. Vector EA plus vector AH equals vector DE. This is just the addition of the vectors. Now, we could draw the same diagonal we did with the geometry proof method for the quadrilateral. And since we got this vector, we have to find vector BD as well. Now, vector BD will be, let me select the color, vector BA plus vector AD. So vector BA plus vector AD. This one will equal to vector DB. Alright, now we know that AE is equal to EB, and AD is equal to AM is equal to HD. Sorry for that. Because it is given that there are midpoints. Point E and point H are midpoints. So what this means essentially is that if you double this vector equation, you will get these two vector equations to be equal to each other. Now, if these two vector equations are equal to each other and their direction is the same, you know that the two vectors are parallel. So you proved line segment EH is parallel to line segment DB, or BD, and you could use the same method to prove the other sides of the parallelogram until you get all four sides. And that is an AMC 10 question, and that is a way to prove that the shape inside a quadrilateral connecting the midpoints of them are indeed a parallelogram. Now, you guys could try to prove the first one. I talked about how the area inside the area of the parallelogram is half of the area of the big quadrilateral around it. This is a trick question, and you guys could try to solve it on your own, and I'll be posting a video about how to solving this later. Alright, thank you for watching.